Hello students, now we will learn about venation in leaves. What is meant by venation? Arrangement of veins and veinlets in leaf lamina is called as venation. Arrangement of veins and veinlets in leaf lamina is called venation. So, basing on arrangement of veinlets in leaf lamina, how they are arranged. There are different types of venations. If the veins are arranged in a network like, then such type of venation is called as reticulate venation. If the veins are arranged in parallel to each other, then that type of venation is called as parallel venation. But in some types of leaves, both types exist. Such type of venation is called as furcate venation. So, you can write venation, it is of few types. First one, reticulate venation. Second type, parallel venation. Third type, furcate venation. In case of reticulate venation, veinlets are arranged in a network like. So mostly such type of venation is seen in case of dicots. So we can say reticulate venation is the characteristic feature of dicots. If we go for diagrammatic representation of this, the main vein we can draw in a network like. Like this. So if you see here, this is network like venation. It is a characteristic feature of dicots. And this reticulate venation, it is again of two different types. One is unicostate. Unicostate reticulate venation. Next, multicostate reticulate venation. Under unicostate, we can take the same example like one leaf. Like this. So we can say there is only unicostate means leaf having one midrib only. So examples we can take under unicostate as leaf of peepal tree, or we also can say leaf is Ficus religiosa. Under multicostate having many midribs or many main veins. If you go for diagrammatic representation of multicostate, again it is of two different types. It is of two types. So those can be written as, first one, convergent type of multicostate reticulate venation. Another one, divergent type of multicostate reticulate venation. Under this, if we go for diagrammatic representation, we can see this converge type in Gigipus and Smilax. So we said that there are many midribs. If we go for diagrammatic explanation, so one midrib, again other midrib, other midrib. So other one like this. So totally here in this diagram, we have seen 1, 2, 3, 4, 5, 6 number of midribs here. So example under convergent, Gigipus and Smilax. Gigipus and Smilax. In the same way, in case of divergent multicostate reticulate venation. Here, convergent reticulate venation, if you see, all the midribs have started at one point. They all ended at one same point. Ending of all midribs at common point. In case of convergent type of reticulate venation. In case of divergent multicostate reticulate venation. Here, the midribs are not joined at same point, but they are dispersed to either sides. For suppose, one midrib has arisen, other midrib has arisen, other midrib. See, all the midribs are joining at same place. But here, this midrib has ended here with this leaf. This midrib has ended here, and this midrib has ended here. Here there are 3 number of midribs, but they did not join at one common place. They have diverted to 3 different directions. Here we can see reticulate venation only, like a network like. But here the counting of number of midribs is important. So I did not mention initially the network like midribs. So here there are 6 number of midribs, but all joined at one common place. Here, in case of divergent type of multicostate reticulate venation, midribs have been diverted to different directions, but they did not join at one common place. So we are giving a term like divergent. So this is also reticulate venation only. Like this. So under divergent reticulate venation, examples are vitis, that is grapes. One best example is vitis. Next, we will write one point related to divergent multicostate reticulate venation. All main veins or midribs are dispersed to either directions and are not joined at common point. So this is about divergent multicostate reticulate venation. Parallel venation means veins are arranged, veins and veinlets and veinlets all are arranged parallel to each other. So here, like reticulate venation, this parallel venation, it is also of 2 types. First one, unicostate parallel venation, but here it is unicostate reticulate venation. Here, multicostate parallel venation. Parallel venation I am representing as P and V. Under unicostate parallel venation, example is banana. Banana is having one thick midrib like this. Midrib. Next, the leaves are arranged we said that all the veins and veinlets, one midrib will be there, so it is called as unicostate. The veinlets are arranged parallel to each other. All veinlets are parallel to each other. Next, coming to midrib member, it is having, we are telling it is unicostate. So this unicostate parallel venated leaf has one midrib only. Next, coming to multicostate parallel venation. It is again of two different types. That is convergent parallel venation, divergent parallel venation. Under convergent parallel venation, though the leaf gives rise to many midribs like this, all midribs are joined at one common point. So here we have represented 1, 2, 3, 4, 5 number of midribs. All are having parallelly arranged veins and veinlets and only. So here there is no network like. There is no network like arrangement of veins and veinlets. Here we can write examples under, and all the main midribs are joining at one common point. You can write examples like grass, wheat, bamboo. Under divergent parallel venation, one midrib, second midrib, third midrib, which are dispersed to either directions. So we can say there are many number of midribs, not only 3, we will draw more. One, 2, 3, 4, 5, 6. So we have represented 1, 2, 3, 4, 5, 6 number of midribs which are dispersed to either direction. Here also all the veinlets are arranged in parallel form only, like this. Like this. So in which types of plants can we see such type of divergent parallel venation? In a date palm leaves, which we call as fan leaves. Date palm leaves. So here again you'll write that same point. All veinlets are midribs are joining at one common point in convergent, but here in case of divergent, all main veins are dispersed to either directions. Midribs joined at a common point. Here in case of divergent, all midribs dispersed to either directions. So this is in case of convergent and divergent type of venation. And parallel venation, here we have said that it is a characteristic feature of dicots, reticulate venation. But parallel venation, characteristic feature of monocots. There are some exceptions in case of parallel venation and reticulate venation. So under reticulate venation, exception of dicot but having parallel venation. So we will write exceptions here. Exception is dicot with parallel venation. That is corumbium. Corumbium, C-O-R-I-R-U-M-B-I-U-M, corumbium is the exception of dicot but having parallel venation, because we said that dicots having only reticulate venation. In the same way, in case of parallel venation also. The monocot with reticulate venation, example is colocasia. Exception in monocot with reticulate venation. That is colocasia. Colocasia. Next one, furcate venation. In case of furcate venation, we see both reticulate type and parallel type of venation. So examples in which plants can we see such type of venation is ferns, which we study under pteridophytes. So ferns show furcate type of venation. We see both reticulate and parallel venation. Every time the branch gives rise to two branches separately. Branch gives rise to two branches always. In case of some types of ferns and pteridophytes, not all types of ferns.